My name is Karl Stroetmann, and just to give you my background, I think this is important for understanding what I'm going to present. I'm not an engineer. I'm not an IT expert. I'm not a software guy. I am a social science guy. So my initial education was in business administration, economics. But since 1992, I am with Empirica in Bonn, and through some incidences, so to say, I got into the health sector, and we developed together, to a large extent, with the European Commission, with many colleagues at the European Commission in those days, those early days, what is called today digital health. Initially, it was electronic health, or e-health, and ICT, information communication technologies in the health sector. And we got into the health sector and developed this field. And now here at Empirica in Bonn, Germany, are specializing. And we are just starting a huge 19 million euro project on semantic interoperability with respect to medicinal products globally, particularly with American colleagues. So, otherwise, Empirica is a private institute, and we do a lot of strategic studies. We do a lot of economic analysis, but we do not IT analysis in the technical sense. So I cannot tell you details of artificial intelligence mathematics, but I can give you a broad introduction, which hopefully will help you to understand what we are talking about. I like to start with the epigraph, and this will also give you my insight into this. I believe that technologies are here to help us, that human values and needs will have to shape technology and not the other way around. And that artificial intelligence, which is in the essence a big basket of innovations coming to fruit in the health and many other sectors, has to be human-centered innovation, has to service what we need, and thereby can support what we do and how we improve our living and our life experience. So I will first briefly look into the definition of artificial intelligence. Then I will give you a brief introduction into the history, because I think to understand the history of artificial intelligence is very enlightening. And then I will give a brief overview over technology. And I understand in the following two discussions, you get much more details on technology. And I will give also an overview of artificial intelligence applications in health. And perhaps the most interesting things for those who are in practical applications, who are not developing artificial intelligence, but who have to use it or who are expected to use it, will be the challenges we encounter. Okay. Intelligence. Intelligence is a very difficult concept. And many people talk about this in qualitative terms. It's called the capacity for learning, for reasoning, for understanding. But this in itself is, again, has many meanings to many different people. And we get to a higher level of intelligence when we talk about grasping truth, understanding relationships, analyzing facts, what is not a fact, what is meaning. But all of this does not allow us to really measure intelligence. And as long as we cannot really measure intelligence, it becomes very difficult to become more concrete in what we talk about. And I have here a definition by Marcus Gabriel. He's a young German philosopher who has been looking into the aspects we are discussing from a philosophical point of view. And for him, intelligence is our ability to solve a problem within a certain time limit. which is a very restricted definition of intelligence, but which is a definition which might be useful when we talk about artificial intelligence. And you can, of course, understand a little bit about intelligence when you look at the antonyms. The antonyms you find are ignorance, stupidity, ineptness, and many other terms. So you go to the next one, please. And intelligence, when we talk about artificial intelligence, I like to contrapose it with biological intelligence. And we already talk about intelligence in plants or trees. I don't know whether you are aware that plants and trees can communicate with each other, that they can react. If like little animals are coming and eating their leaves, they react, some plants, by creating poisons against these animals. And some people already call this intelligence in living organisms. We have probably definitely intelligence in animals, particularly in monkeys, and they're particularly in apes. And then, of course, with the Homo sapiens, we talk as the animal having intelligence. But what really constitutes human intelligence, as you have this quote here, is also discussed widely, but again, it is very difficult to really understand, to grasp it in a terminology that we can handle it more than just, let's say, in philosophy. Please take the next slide. And we can contrast this with artificial intelligence. And artificial is manufactured, unnatural, non-biological. And there has been the proposal to not so much talk about artificial intelligence, because artificial is compared to biological, almost anything which is not biological, but rather focus on machine intelligence. Because what we are talking about, artificial intelligence today, is mostly embedded in machines which are created by human beings. And the antonyms are natural, biological, real versus artificial. But does this really help us? Go to the next slide. And there we have more definitions of artificial versus general intelligence, because there is the theoretical aim to integrate biological and artificial intelligence into something like general intelligence, a robust theory of general intelligence, human-like or otherwise. And this remains, as you have the quote here, very elusive. We have many, many attempts. If you look around, you find almost hundreds of publications on these topics, but it is very difficult to come up with a very definite, useful wording of what we are talking about. And as you see here, about 50 to 100 years ago, the original ambition of artificial intelligence was the creation of software and/or hardware systems with general intelligence comparable to and ultimately perhaps greater than that of human beings. And you see the quotes I have here are from 1980, so they're almost 40 years old, when people were already discussing these kind of concepts. Go to the next slide. And what is probably more helpful is the differentiation between weak and strong artificial intelligence. Weak intelligence is what we will be speaking more or less in the rest probably of this whole seminar. Weak artificial intelligence is systems that carry out specific, quote, intelligent behaviors in specific contexts. And this is very important to understand today's discussions on artificial intelligence. It is very specific behavior for specific tasks. So all the machines we have and where we talk about artificial intelligence applications are very task or problem specific. And there is not a trace of general intelligence that you can use one task right now and 5 minutes later a different task, and tomorrow completely different task with the same machine. So we have here a very narrow perspective on intelligence. And this is compared with artificial general intelligence. It's a very fuzzy concept, and it's aimed at bridging the gap between current artificial intelligence programs and the types of artificial general intelligence systems commonly known in fiction. I mean, when you have fiction, if you have movies, there you see artificial intelligence, which is like human beings or is even more capable than human beings. But you see already here's a reference to commonly seen in fiction is that in the scientific field, in the business field, and the health field, we still have not come to grips with any of these kind of far-reaching concepts. And strong artificial intelligence is then compared to weak or cautious artificial intelligence as implying thinking machines. And this is obvious that by now we still have not, and probably some philosophers say will never have, thinking machines. Machines which can express intentionality. As said, they set their own goals. They are mentally capable of human traces and things like this. And so strong artificial intelligence is kind of the long-term aim, but we do not even understand our own brain. So how can we then build machines who should replicate our brain? Next slide. And here you have a slide which I find much better to understand what are we talking about artificial intelligence these days. It is not coming from a precise measurable definition, but it's more coming from what are the functional capabilities of artificial intelligence applications. And these are really impressive. Artificial intelligence can already support our perception to find out how the world looks like. It can help us in the learning field, machine learning, deep learning, and we will come back to this. Deep learning means to automatically build, adapt models of reality. And this is right now where the most discussions on artificial intelligence focus on. They focus on machine learning. But there is much more to artificial intelligence, like knowledge representation. Knowledge representation to communicate models of the environment in which we are living in any field, in business, in health, in environment, and so on and so forth, is already happening. And this is a very important aspect. The next kind of level, you might say, is reasoning. To infer and generalize models based on existing knowledge. I think here we are not yet very far. Some of you might know the attempts by IBM, the IBM Watson machine. These attempts are at least 25 years old, but still, as at least the field in health shows, IBM Watson is not yet very far advanced with respect to generalize new models based on existing knowledge. They pretended that they are able to this, but if you look at the literature which has been published over the last 2 years in health shows, they are just able to replicate what good experts can do, and a lot of the reasoning in IBM Watson Health is based on the reasoning of experts in the field and not more. Artificial intelligence can help us in planning, in evaluating performance and making decisions. Here we have seen big progress in recent years, and I will come back later at the end of my talk the challenges this implies, because we really have already situations where the machines take over decisions. And here we get into big ethical issues. And then, of course, acting to manipulate and move around in the real or virtual world. This again is opening up big theoretical and practical issues, ethical issues, moral issues. All the discussion about autonomous driving focus on this, because in the end, an autonomous car is acting on its own. And this has many implications for further activities. Next slide. Okay, a short history of artificial intelligence. I will just scan this, but this is very interesting because if you see already in 1315, a Spanish guy, Ramon Lull, has talked about reasoning by artificially implemented in machines. And the interesting background about this is, and this guy was rediscovered only 5 years ago, his publications were lost for, I don't know, 500 years. He developed something which is very similar to today's artificially implemented rules in machines to prove that God exists. So he was not applying this to our daily problems, but to religious issues and trying to artificially prove that God exists, that the Holy Maria is indeed a virgin, and so on and so forth. But now some people even think he is a kind of godfather of informatics. Around 1600, Francis Bacon already developed ideas to fetter discovery, so to support discovery by artificial rules. And David Brewster, 200 years later, cited him, and he said, this will never happen. This is not possible. But already 400 some odd years ago, Francis Bacon was thinking about something what we call today artificial intelligence. And I myself was surprised to learn that the least squares method of a regression is already 200 years old. I didn't realize this. And still today, many statistical problem solving in artificial intelligence is based on this least square method and its many, many, many developments over the following 200 years. And the basic artificial intelligence concepts, as we talk about today, were developed by Alan Turing and by two guys, McCulloch and Pitts, around 1940, 1943, and they published some very basic papers on this. 1948, we had then Norbert Wiener. I don't know whether many of you still know him, cybernetics, or control on communication in the animal. He was also concerned with animal intelligence, you might say, and the machine. And also what we call today artificial intelligence was already embedded in all the theoretical and practical work on cybernetics. And the famous Turing test, which says, if you communicate with a machine and you are not sure, or you are almost sure it's a human being, but in reality it's a machine, then we have really created artificial intelligence. But this Turing test developed, or the idea of which was proposed by Alan Turing in 1950, is actually a very limited topic, limited context, because the Turing test is usually applied to a very specific problem situation. And in a very specific problem situation today, machines can kind of start to get into dialogue with human beings. But once you go into other areas, they fail totally. So this Turing test, depending on what you mean by intelligence, is not very useful here. And the first self-learning algorithms everybody's talking about today are also 60 and more years old. And the birth of deep learning, the big hype today, again, you see, was founded in 1965. Next slide. Okay, let me talk a little bit about the underlying technology, but I will try to do this very short because later you learn more about this. So basically, artificial intelligence is about algorithms. Algorithms are a self-contained sequence of mathematical instructions or rules that will give us a result for a specific problem. And I think this again is important. Artificial intelligence up to today is usually about highly specific problems in specific contexts. And this makes them so powerful on the one hand side, but on the other hand, extremely limited. Statistical methods are a basis of much of artificial intelligence. Deep learning, machine learning, pattern recognition, deep neural networks, these are the hype terms today in artificial intelligence, and we will come back to this. Natural language processing, which also in health has been discussed, I think, for 30 years, is artificial intelligence. Complex analytics for knowledge discovery. There are almost daily developing new fields, new algorithms, new models, how to discover knowledge. And here we might see big explosion of knowledge in coming years. And then you have the big simulation models, virtual physiological human, where we try to simulate the body functions, diseases, to help doctors to better understand, to reduce clinical trials. And again, here, work is going on for 20, 30 years. And today it's all called artificial intelligence. Next slide. So why, in spite of the long history of artificial intelligence, is all this hype right now? And this hype is because all these concepts, all these ideas, these different approaches, different methods, different statistical tools, and so on and so forth, have gained a completely new dimension due to the computing power. The computing power, as it's implemented in hardware, in chips, is incredible compared even to what we had 5 years ago. There is an absolute exponential explosion of computing power, which makes a lot of, let's say, mathematical work possible and can be handled by human beings, which 5 years, 10 years ago was totally impossible. We have big advances in theory, in algorithms, and we have big advances in storage capacity and access speed. I mean, if you look at your Google search, other searches, how we communicate here right now together, this also implies huge storage capacity in the background, huge speeds of access. And this then also combined with big data sources, shared, annotated data. Particularly in medicine, we do not just need data, we need annotated medical data, we need annotated images. So the big machines who are to analyze this understand what they are looking at, so to say. All of this is the basis of today's explosion in artificial intelligence. And of course, it, particularly in medicine, involves interoperability, where we are still lacking a lot in medicine, data integration. More and more, we talk about cloud services, that we don't have the computing power, the storage, and so on at home or in our hardware in the, let's say, in the basement of your building, but that it's somewhere around the world, stored wherever it is. And I remember still, that was about 10 years ago, I was at a conference in Phoenix, Arizona, and everybody was talking about the coming cloud services. Cloud services was a big hype in those days, but it didn't work yet. And today it's daily activity for all of us. And the merging of all of these techniques has allowed for today's wide implementation of artificial intelligence. I think this is also important to understand. All these technological developments in many different fields combined have allowed the progress in artificial intelligence, which we are observing right now. Now, the next slide, slide 17. I think I will not go into detail into here because I assume that the later calls presentations will explore this in more detail. I mentioned that deep learning, deep neural networks are the big basis of a lot of what is called artificial intelligence today. And what is important here is, on the one hand side, we have the input layer. These are the data, the images, whatever you use as input. And then you get what is called here hidden layer 1, hidden layer 2. And we are up now into mathematical models, I understand, with hidden layers of 1,000 and more. And here we have a big problem that experts told me, mathematical experts, we do no longer really understand what is happening within these hidden layers. And we just get output. And we can look at the output. But we don't really know what is hidden into these hidden layers and what activities are going on there. And this, of course, makes it then in the end right now quite often totally impossible to judge the output layer, to judge what is this artificial intelligence system telling us. And if we do not understand what's coming out there or how it's coming about, then particularly in health, we will see later, we are into trouble. Because we cannot just use something which the doctor does not understand how it's working internally to a patient and then hoping it's just good to the patient. Go to the next slide. These are different types of neural networks. I just wanted to show you that the whole system is extremely complex. Don't try to understand the details. I don't understand them myself. I just found this very nice presentation, and it already gives us a glimpse at how complex all of this is. This, to me, is an extremely important statement. It's from the Vienna workshop on digital humanism. There are some global experts assembled in Vienna this April, I think it was, and they tried to put some perspective to all of this. And these are some quotes from their agenda, their publication, where they say, we experience a metamorphosis from the stand-alone computer to the global operating system. They call this the Digital World 5.0, which will digitalize everything and automate work and thinking. And this is kind of a vision of what the future might be, which is on the one hand side very optimistic and great, on the other hand frightening if we do not understand what is inside all of this. How does this Digital World 5.0 deal with ourselves, with human beings? And how do we get dependent on this? And as I say, this is already coming about permitting work, leisure, politics, professional, private life, everything. And how will we stay on top of this? I think this is going to be one of the key issues, and particularly also in health, where in the end we talk about life and death, and the doctor has to stay on top of this. Take the next slide. Briefly, quantum. Everybody talks also about quantum computing. I believe quantum computing is at least for practical applications the 10, 20 years ahead of us. But once we would get into quantum computing, then the future of artificial intelligence would again change dramatically, because quantum computing opens up totally new possibilities. But the recent hype on, I think it was a quantum computer by Google, is nice, is interesting, but for practical problems, totally irrelevant. But this might change over the next 5 to 10 years. Nobody knows right now. Okay, next slide. Now let's briefly go into application in health. I would want just to give you a few examples. A typical and most widely cited example is radiology. And this makes a lot of sense when you think that 2 billion billion chest X-rays images are produced worldwide every year. Every year, 2 billion. And radiologists have to look at this. And this takes an enormous amount of time. It's very boring in the end, I guess, if you just look at hundreds of images every day. And if a machine can do this and if artificial intelligence can help us here, it would be fantastic. And this is a field where already the first producers of X-ray machines, of computer tomographs and so on are implementing artificial intelligence systems into their machines. As you see here, they can interpret the scans 150 times faster. So it will save an enormous amount of time for radiologists. The accuracy right now is so-so. If it are less experienced medical doctors, it is better. So it helps them a lot. If it are really good radiologists, it rarely outperforms them. And as I mentioned earlier, IBM Watson in Health, they have a cancer decision support system where there are a lot of studies now being published, at least 10, 15, some very interesting from Korea. They show that Watson sometimes replicates what very good radiologists can detect on cancer, yes or no. But there are also quite a few publications which show that IBM Watson is still less accurate and less reliable. But maybe it will learn. But in the end, the decision supports the recommendations the system produces are the suggestions by a few cancer experts at the hospital in New York and not coming out of the machine. This is also to put this a little bit into perspective. Let's take the next slide, slide 23. In pathology, it will hopefully develop to become very helpful because pathology is a much more complex field than radiology. In pathology, you have so many different types of slides, of pictures, of images to interpret, to look at. And if artificial intelligence can help us to improve the assessment of pathological images, this would be really, really helpful. But the big thing we have to understand here is the machines themselves cannot do this. We have to train them. So we need hundreds, thousands, and millions of pictures which are absolutely precise from which these machines can learn. So the machines cannot learn on their own. They learn from the pictures, from the data, from the knowledge which is inputted by human beings. This is also very important to understand that the artificial intelligence, once we have this very precise, very good input data, can analyze the rest much faster than human beings. But if we have bad data input, then of course we get bad data output. Similar situation we have in cardiology. And go to the next slide. Here you have a list: dermatology, gastroenterology, genetics, predicting suicides. There are many fields where artificial intelligence application support medical professionals. At least people pretend this can be done, and there are some initial studies showing how it might be done. And the last bullet is robotics. Robotics is also coming to the forefront. That's a combination of artificial intelligence systems implemented in robotical machines, robotical persons, robotical whatever, like in care services, might also help us to cope with the aging of our societies. But these are all developing fields. Nothing is really working in the daily routine yet. Next slide. Then we have other application fields: health systems, health service provision, improved workflow, and potential for reducing medical errors. The typical decision support systems. When I started in this field 20 years ago, everybody was talking about clinical decision support systems. and we didn't talk about artificial intelligence. Today, we are still using similar systems, more improved, and today it's artificial intelligence. There are first applications to help patients, and there are also first applications to management the workforce. And here we come into systems which autonomously even decide on workforce. Select, direct, control, promote, and even fire. I think it was Uber in California, the taxi service, that they have a system where they not only promote, but also fire people, not by human beings anymore, but based on decisions artificial intelligence systems prepare. And here I think we transgress an ethical border, because what is happening, the machine, what kind of input data, because something goes wrong, the machine cannot decide. I think here we still need human beings. Okay, next slide. Here I want to give you a brief exemplar. It's a backup patient decision support system. And this is to help doctors and patients in dealing with back pain. I'm not presenting this for you to get into any details. I'm presenting this to show how a complex artificial intelligence system might be constituted in the health sector. And the backup system has a research platform where you get new data, new publications, empirical data from statistics. They have a clinical professionals platform, which helps with artificial intelligence algorithms clinicians to make better diagnosis and better treatment decisions. And it involves a patient self-management platform to support patients in dealing with back pain. And they use machine learning, neural network techniques, statistical models, and other algorithms. And the more complex system is on the next slide. Here you have a conceptual diagram of this system. And again, don't go into the details of this presentation, of this picture, but just see how complex let's say, simple artificial intelligence system for dealing with back pain might look. And this is what I believe is often overlooked when you talk about artificial intelligence in health, how complex this system can become. You see on the right-hand side, you have the research platform. On the left-hand side, you have the professional platform with all the different aspects. And the green box is the self-management platform for patients. And to keep such a system going, you might need a whole, not even small startup. You might need 20, 30 people to keep this going. And this, I guess, is also one of the big issues we have to deal with when we talk about the future of artificial intelligence, like in health. Go to the next slide, challenges. Yeah, next slide, slide 29, the artificial intelligence chasms in health. These are very important aspects to understand about the applicability or not of artificial intelligence in the health system and probably in many other fields. What we see right now are mostly publications which validate the performance of an algorithms. But the validation on past data of an algorithm is not equivalent to demonstrating clinical efficacy. So all these studies do not tell us how efficacious these systems would be in a clinical trial. You see, and even if we have proof of concept in a clinical trial, a prospective clinical trial, this does not necessarily tell us what the proof of the concept will be in improving routine clinical outcomes. In clinical studies, we talk about efficacy and not about efficiency or impact, because this is a controlled environment. But the routine daily clinical health service is not a controlled environment. It's a very fuzzy, very complex, and a very difficult context where you have interruptions, where you do not have the strong controls you have in clinical trials. And many drugs, for instance, demonstrate good efficacy in clinical trials, but in clinical routine implementation, there is almost no effect. And we are far away from demonstrating this for artificial intelligence in health. And another chasm people say is, okay, if we have now all these new insights and we have these enormous mathematical models which can predict many, many things we hope for, we foresee that we see a prediction of the risk of an adverse outcome where we have no therapy. This seems to be a real problem in health. And what do? Does it make sense to tell a patient, yes, you will have this disease over the next 5 years or so, but we can't help you, we can't treat this? Or should we ignore this and not tell patients? So this is just to inform you that artificial intelligence might have some new aspects which we have never dealt with in healthcare. Next slide. This kind of puts this together in a summary, what I have said on the challenges. To validate a digital neural network in silico, as most of the studies do right now, is far away from clinical validation in a clinical trial or from real-world medicine. And only if we have covered successfully this step, then we can think about wider implementation in healthcare. And I would expect this to be away still 5 to 10 years. We will see a lot of research. We will see a lot of these posterior studies, of these studies looking at the past. We will see many fewer clinical validations in the real world medicine, and then go from there to diffusion of innovation in healthcare. This takes, as studies show, up to another 10, 15 years. Okay, go to the next slide. Yeah, the ethical dilemma, which is something close to my heart, because I think it is very important in health that the artificial intelligence applications must be driven by human values and needs. And here we have the problem that people think about integrating ethics into the machines, but values are culturally determined by tradition, by religious beliefs. They are different by country. How can we implement such kind of rules into artificial systems? And who controls this and who decides on this? And here I think we still need much more work and much more thinking before we really come to clear decisions on this. Next slide, missing business models. I mentioned this earlier. We need a lot of input data, and we need good, high quality, annotated data in healthcare. We need to adapt these systems regularly to new regulations. We have to adapt these systems to new knowledge, new medical drugs, to new types of medical intervention. So what we really need is a continuous learning with respect to many aspects of these artificial intelligence systems. Who is going to do this? Who can make this into his business model? Who will pay for this? Unless we have solved these problems, we can do a lot of research, but it will not end up in the medical practice. Next slide. Bias of input data, widely discussed. The input repeats what people believe. I mean, the most famous example is probably in the United States, in the legal system. What people put into the artificial intelligence legal systems was their past history. And of course, these systems then decided that 80% of those who have to go to jail are black people, because they just repeated what was before. There was no new knowledge. It was just condensed and repeated. And we must avoid this. You know, and interesting is the picture recognition is class related, they found out. You know, And how do we get this bias out of this? How do we get also bias which might be in studies involved? And how do we get to the, let's say, real knowledge? Nobody has a real answer to this, but we have to be aware of these issues. Next slide. Further challenges. Yeah, what is the quality, reliability, and safety of these artificial intelligence systems? You see, these are not just a simple machine. These are interplay of various input devices, of complex algorithms, of various output devices. You see, and a big example of what can happen if we don't test them really is the Boeing 737 MAX accident. I mean, 2 airplanes came down because artificial intelligence in these machines failed. And this demonstrates us how careful we have to be about this. There are fantastic opportunities, but we have to be careful about this. And like here, where I'm living here in Germany, we are thinking about regulation and certification of artificial intelligence systems and applications. But how can you do this? Nobody knows. How can you understand what is happening in these deep learning systems? And if you do not understand what is happening, how can you certify this? Data protection is a big issue. The cybersecurity of the connected systems, of course, cybersecurity is becoming a top issue globally, legal issues. And the last point to me is extremely interesting and perplexing. The individual artificial intelligence system we might be able to understand. But the tendency is to combine different artificial intelligence systems. And then our understanding really fails. How do they interact amongst themselves? What kind of decision is coming out at the end or recommendations? Nobody right now will be able to understand this. So this will be a key aspect in the future to look at. Last slide, slide 35. I personally believe there's a fantastic potential in artificial intelligence for safer, better healthcare. It will allow us to better explain, hopefully, what is happening in our bodies, what is happening when we get a disease, and how we can cure it. And it will be an important building block in what is called the learning health system, where we have continuous feedback from input through the treatment and then through the health outcome data, improving our knowledge. So artificial intelligence in healthcare hopefully will help us here tremendously. But we have to be aware of the caveats I mentioned earlier. And it will be a huge collaborative effort. And if Europe wants to sustain this and to remain or become a world leader, we have to create a European artificial intelligence for health or for whatever program and platform. Because otherwise, neither Estonia nor Germany nor any other single European country will be able to compete on its own with Asia, with China, or with the United States. So my kind of vision is, yes, fantastic opportunities, but yes, still enormous need for further improvement, for further understanding, and for future work. So I stop here. There are 2 more slides, an acknowledgement, which you might show, and at the end you have my address if you want to contact me. And I stop here and thank you all for listening and hope I could give you some good insights. Many thanks. Back to Tallinn.
Yeah, thank you. Sorry. Thank you, Karl, for a very interesting presentation, but at least for me, there were more questions than answers. So
yes, that's the case. I fully agree with you,
yeah.
But I can't help it.
Yeah, for those who are online, it's also possible to ask questions. Just drop a line, either in YouTube or Facebook, and we will pick your questions from there. But in the audience, right here, do you have any questions? Well, I have just one. You listed so many obstacles, and just can you bring out one really crucial thing we should overcome before we can have those AI solutions not only in radiology but also in mental health, for instance. Can you bring out like one really important factor we should change? Is it the technology? Is it legal background? Something in our head, our thinking? What is your opinion, Karl?
Oh boy, that's a difficult question.
Yeah, and if you answer this, then we have a very good way to go on or to continue with this. So it's a million-dollar question, yeah.
You see, I think a basic issue which I come across all the time is the input data. You see, and the input data are useless unless we have a good model behind this. So artificial intelligence is kind of a model, a mathematical model, and which might be extremely complex to go from some input data, and input data means knowledge, understanding, but also facts, how to recombine this so to get an output which tells you something. And like in mental health, I could imagine there are so many scales you use in mental health. How can the application, let's say you have a patient which has to fill out 2, 3, 5 of these scales to judge what kind of mental illness he or she has, what degree it is, how they are related, that artificial intelligence will help the doctors based on learning from these different data to better diagnose. This would be the first step. And once I have a better diagnosis, then of course I can go the next step and also try to use artificial intelligence based on this diagnosis, based on the different types of therapies, what might be the optimal therapy for this individual patient. You know, and based hopefully, let's say, on knowledge of the last second, what have the recent publications, what did they tell me about this? But this suppose you have a patient who is willing to cooperate here or not. I don't know. I'm not an expert in mental health. I have to understand a little bit about the quality of the scales. I have to see that the input data from the patient filling in these scales are appropriate. How do I, for instance, understand, is there cheating going on from the side of the patient? Can artificial intelligence help me? And who, in training these artificial intelligence systems, who can supervise this machine, so to say, that the output is really the correct output? I mean, we have interesting examples and experiments that artificial intelligence machines can work very well with a given situation. But once there is even a little bit change in the input data, there are examples, they come out with totally crazy results because we do not quite understand what is inside. And how do we then discover on the other side, on the output side, that this is crazy? In spite of artificial intelligence, it is totally unintelligent. You see, and this is where, at least in medicine, we still need the critical doctor. The doctor with a good background, with a good understanding, who can use this artificial intelligence system to help him or her, but who is not kind of the prisoner of these systems. They have to be tools, they have to help us, and they can improve things, hopefully very good, but they need high quality input and a good understanding on the side of the applying doctor.
Okay, thank you, Karl. Any questions online? We have a few questions online.
So one question online from Helena is that since machines are powered by AI, what does machine behavior exactly mean?
This is, I don't know whether we really can talk about machine behavior. You see, I mean, I'm not just trying to use the paradigm of the autonomous car. If a car drives right, drives left, is braking, if this is behavior, yes, then the machine would behave in this sense. You see, you could also talk about a cybernetic cycle, just a simple cybernetic cycle controlling your temperature in your home, turning on and off the valve to improve, to put more heat into your room, less heat, and so on. You could talk this behavior, you know, but I don't think this behavior in the sense of a human being is meant. If I love somebody, if I enjoy something, if I hate something, I think this might also be behavior. You see, I'm not a behavioral expert, so I can't tell you exactly how do I define behavior and how do I measure behavior. And this, of course, is also a problem in all of these discussions. We come from different language backgrounds, so we might use the same word in a different meaning. And I would say machine behavior means really how the machine acts or how the machine functions internally. But it's not similar to human behavior. But this is just a guess. I can't. I probably would have to ask an expert, and he would give you 5 opinions at the same time. Maybe. Sorry about this.
Okay, thank you, Karl.